this is our title. And every year I look forward to this presentations, and this one particularly, perhaps a bit more so. Now, I'm actually sort of on a sequel to what Sevi and Sergio presented yesterday, the future of NetPoint. And I'll explain it by touching on this book, great book, by the way. And I read it, and I'm grounding myself now after reading the book. And it's very repetitive. It just goes story after story. And somewhere along the way, you are convinced that you got to try this out. And, you know, so that's how I felt. When the book was over, they had this wonderful appendices, the physics of grounding, electrophysiology. As a sort of a scientist, as an engineer, that was awesome. So basically, the appendices really give you the, the science behind this whole thing. So today, I'm sort of like that. Sevi and Sergio should have blown your mind yesterday, as they have mine every time I see what they're doing. Today, I sort of give you the algorithms behind it, sort of the protocols, so that you can sort of see, how elaborate this is, even though it looks so simple when you actually will be using Summit. I have this slide mostly, if we haven't met, to make the point that I've been around the horn a couple of times. This year, PMA will turn 50 years on August 30th. So, and I was also an academician. I got my PhD. I taught for 17 years, but primarily, I'm a practitioner, like most of you in the audience today. So I'm your peer in that sense. Now, PMA is a consulting firm, project management consulting firm. So you got to ask yourself, how is it that a firm like PMA is doing software? Most project management firms don't have a whole innovation practice. We have multiple patents for our algorithms and protocols and many more in the works. A little while back, it became clear to us that scheduling software was more like handicapping scheduling than helping it. And we needed to basically advance the status quo. And in general, just keep advancing scheduling software, because the whole thing is about predictability, nailing the completion you predicted 3-4 years ago. And if you don't have scheduling software that can really help you, that is, makes your schedules useful and accurate, your ability to predict completion is going to be, less than optimal. So we want to projects to complete on time every time they're out. Now, a little bit of a going back to the future, so to speak. On the left side of this slide, I'm sharing with you where we've been for the last 10, 12 years. Clearly, GPM enables a collaborative platform for scheduling that is visual. And it makes things simple. Non-schedulers can come to the table once again and make sure we have better schedules. Kelly and Walker development of CPM was to basically replace bar charts. I wonder how they feel about the fact that most schedulers today are still stuck with Gantt charts. So we want to go back. We wanted to honor the original invention, which is to use timescale networks as visuals. And we've done that. We talked yesterday about a method we created, a diagramming method. So the other thing is, most schedulers are very focused on the information right at the data date. How did that come about? Well, the CPM algorithms are inert, left of the data date. You don't get any total flows in the critical path. Well, consequently, people sort of dismissed what's going on left of the data date. But we understand the wealth of information that should be accumulating left of the data date. But in order for people to be enthused about and give it some serious thought, we had to have an algorithmic network left at the data date. We've done that, and only GPM can do that. And I think that that enables us to be more mindful about what's happening as the project advances. Sergio yesterday talked about a risk that has been left out of the schedule risk assessment since 1963. When Vance introduced schedule simulation in 1963, that was amazing. My whole PhD thesis was about network simulation, all kinds of ways, quite a deep dive. We didn't realize, though, until 2012, that we were getting only an early completion distribution. And we've corrected that. We can get a late completion distribution. Sergio's going to show you that today. Any scheduler who continues to simulate a schedule, ignoring his late distribution, is doing so at her or his own peril. So now, where are we going? Today, we're going to talk about machine-generated, summarized, network-based schedules. And you saw this yesterday, on the fly, so to speak. We're going to be fully achieving the learning potential of level 3 schedules. I'm just going to barely touch on that today. Next year, should we be fortunate to have you join us again, you'll see this in more detail, as well as the last bullet here, having us build data augment our predictive acumen. So this is kind of a roadmap before and going forward. Here's a summary, a synopsis of what density zooming is all about. Manually building a summary schedule from a multi-thousand activity network, it's a challenge. One only the most consummate schedulers can take on. And even so, takes a lot of time, and it distracts them from doing other things that perhaps they are required to be doing on a daily basis. So finally, we're taking on this challenge, and I'll explain why in just a little bit, how we came about making this a priority. Zooming in. Now, we have a lot of schedulers in the audience, and a lot of you, if not most of you, can probably manage a schedule with 10,000 activities, but it extracts, a lot of brain energy to do so. And you hope you got it right. If you don't have tools like ScheduleND and other tools to help you make that reliable, you're taking a chance. Is that schedule useful? Well, I guess it depends how on top of it you are and whether it is accurate. So, I mean, this is sort of a bit of a joke in a sense, but for some people, it's probably real. For non-schedulers, it is their worst nightmare. How would you imagine sitting at a table with your project superintendent, your project manager, and design manager, and laying out a stack of reams of printouts and trying to get them to stay with you. Now, albeit schedulers, accomplished consummate schedulers, they can work with this. I mean, tongue in cheek, I would dare say that critical path and CPM software are guaranteed a scheduler's employment for life, because without those consummate schedulers, I mean, we'd be lost in this with somewhere. So on the one hand, this is probably not useful. On the other hand, we got these tremendous professionals that make it more useful than it seems, but at a great expense, if I may, and effort. So, here's the thing. Having to create a summarized schedule is not a once in a year occurrence. If you are running detailed schedules, which a lot of us do, this is going to be something you do every once in a while. In fact, over a year and a half ago, one of our most consummate project management professionals, a scheduler non plus ultra, uh, sent us an email that said, "Hey team, I just spent a week and a half creating a succinct schedule from a large transit schedule, thousands of activities, and it took 5, 7 days out of my life, 24/7, took me away from other things. Pretty please, can you guys take a look at maybe doing this, automating this for us, and we can go further if we can have the machine help us." So this is how we got to this point. And these are just some of the instances where many of you in the audience today are facing this challenge. For one, the second bullet on the left, if you're going to do a schedule risk assessment and you have a 5,000 activity schedule, which you have to range activity durations, imagine sitting at a table with 15, 20 stakeholders and having to range 5,000, 2,000 activities. Well, that's DOA. That's not going to happen. That's not really useful. It's not practical. I mean, you never get done. So basically, if you're going to do a risk assessment on the schedule, you're going to have to boil it down to a summarized, useful model that hopefully we can range activity durations and simulate and get a good probability, a P80 data as it goes, of completing the project. So again, just some examples. There is a crucial one where thou shall have a summarized schedule. Now, when we created NetPoint, we were trying to solve the problem of getting stakeholders back in the game, having a visual tool that was dynamic, that non-schedulers could follow and partake in. And you were thinking, a few hundred activity schedules and so on and so forth. It wasn't too long though before people said, shoot, I mean, I got to see my schedule better than I'm seeing it on the printout. Let me dump it onto NetPoint and do something with. And a lot of our own schedulers, of course, were using NetPoint to build summary schedules. And it becomes pretty obvious. If you're going to summarize manually schedule, you use NetPoint. There's nothing else really that you can use. So even though, using NetPoint is a great tool to manually summarize schedule, it is quite a bit of work. And the computer is helping you keep the schedule mathematically correct and see it, but it's not helping you build it. It's all human brain creating the summary. And it's iterative and it takes a long time and you got to get it right. And if you weren't with us at our conference 2 years ago, you had a lot of fun seeing our Renis Musa's presentation, what he had to go through to have decisions made on an important schedule in a crucial moment. Renis knew that he wasn't going to walk into a meeting with crucial management, high management level people make decisions that had to be made, on a full day meeting with lots of activities. So he painstakingly boiled the schedule down, had a 40-minute meeting. He was successful. The presentation shows you the thinking that he went through, the protocols that he followed, very disciplined. I mean, just fun to see that you can do that, but a lot of effort. Now, ever since I've been in scheduling, and if you read any published literature, of course, people talk about different level of detail in schedules. Since I got on the scheduling arena a long, long time ago, we talked about level 1 schedules all the way down to level 4. And people were doing this manually into the mid-60s before really software started to come on the scene that could computerize this. And level one is the highest level, least detailed schedule, unless you do even a summary of that, which I call it when I do a level 0, a level O. That is the most conventional way to characterize the detail in the schedule. About 10, 12 years ago, our colleagues in the UK suggested a new method, a new lingo to classify schedule detail. They called it schedule density. And level one is the highest level, but it's also the lowest density. Lower density means less detail. If you were to print out on a printout a 200 activity schedule, it'll only be so many pages and so dense. If it's 10,000 activity, it'd be a heavy printout, okay, much more dense. Basically, density means if you have a building that you're scheduling, you know, how dense is your schedule? Whether you have 20 activities for it or 200. Obviously, the more detail, the more density in the schedule. Now, I want to make a really important point. In the scheduling realm, there are two categories of schedules, strategic and tactical. Strategic are like of foremost importance. Summarize schedules that are built with the stakeholders at the table or with a tremendous amount of input and direction and contribution, called collaborative. These are strategic. This is using people's judgment and experience and a feeling for how the project was bid or budgeted and how is it going to unfold, whether it's the seasonality, the structural access, weather, enclosing the building, at one point in time that you're going to go into systems completion, etc. That it takes some schedulers over the years have figured out how to do that pretty well, but in reality, nothing like the stakeholders responsible to do that. So these are strategic schedules. And if you look down the definition at the bottom, is strategy defines your long-term goals, how you're going to achieve them. Tactics are much more concrete, and they're often oriented towards smaller steps and a shorter time frame. Exactly, like a level 3 schedule. Level 3 schedules are tactical and are developed by schedulers, hopefully with a lot of input from stakeholders, but rarely at the table. And the purpose is to confirm that what's been done before, it's correct at the beginning of the project and as the project progresses. Now, strategic schedules, because they are less dense, have another characteristic in their DNA. Few activities repeat themselves. You may have 2, 3 activities for basement construction on your level 2. You may have 35 on your level 3 schedule. So on a level 3 schedule for a large project, you may have 15, 20, 35 activities that are pretty much the same. What Kahneman calls it belonging to a reference class. Anytime you have repetition, you open the door for the machine to learn, for the software to learn. So level 3 schedules are extremely powerful project control instruments, provided they're used that way, which we haven't heretofore. Not to a great extent anyhow, speaking for myself. Now, this is the textbook. Any scheduling practice standard you read is going to talk about level 1. I don't know, they'll give it different surnames, but level executive schedule, it's usually 1 page. Notice activity durations are in months. And usually 1 page schedule. Level 2 schedule is paper. That's really, if you want to have a successful project, this is really what you need to have. A good, not only a reliable, but a useful master or management schedule. Now we're down to durations in weeks. I've seen them, 100 activities. I hardly have ever seen one beyond 800, 900. I mean, for multi-billion-dollar projects. And then you got your level 3 schedule, which is the workhorse in the project controls, of course, field. Durations now basically within a month. And then level 4, you don't see a whole lot anymore, except some contracting companies have this as a standard. You build a detail from the level 3 for the next 3 to 4 months, all over the project. We used to build back in the 70s with my contracting company I was chief scheduler for. We used to build, boiler house erection schedule, turbine erection schedule, yard piping schedule, etc. So that's how that. So a lot of level 3 schedules tend to have a mix of level 3 and level 4 activities. If you get a schedule with 20,000 activities, your chances are you into level 4 in part or quite a bit. I love this. I mean, Sergio used this yesterday. And I'll let you read the quote. Over elaboration, over parametrization is often the mark of mediocrity. Maybe that's a little too strong, but as a superb statistician, that's how he sees it. And this is so dead on point. All models are wrong, meaning from the day you start, they go obsolete, but some are useful. Now, George was around a long time ago. Machine learning, he didn't have the benefit of that. So I think that at some point in time, when machines augment human intelligence, that the impact of that is going to diminish to where it may just be historical, not current. But for today, that's still true. A little bit more on level 3 schedules, because schedulers spend 80% of the time on these. Again, level 3 schedules confirm the sequencing strategy. I talked about that. The durations on the level 2 schedule, the logic, the critical path at the beginning and as the project progresses. Now, for $250 million contract, that's not a huge contract, 5,000 activities. That's a pretty good size schedule. Now, again, level 3 schedules is what guarantees good schedulers professional career, because it takes a really sharp scheduler, well experienced, trained, well schooled, and to do it, with the eyes wide open to keep it oiled and running well. Software, the software is just basically doing the math for you, but that's about it. And of course, if you do simulation, well, you cannot do that by hand. Scheduling software today is barely scratching the surface of the future power, the accuracy and usefulness of level 3 schedules. So, I think some of the older schedulers probably have a disdain for level 3s, but that's because we haven't really been running them or using them really for their naturally intended purpose. But it's very helpful for now. Now, what do we do today? Shoot, we got a 5,000 activity schedule. We need to show somebody what's going on. Well, we code activities to hammocks and we print out a hammock chart. Kind of a cute name. Called so because an activity bar hangs between 2 dates. There's an activity that sets the one of the bookends, the start bookend, and the other one says the end bookend. So intrinsically, the hammock chart is vertically integrated with a underlying detail schedule because it's rolling up. Think about hammock charts though. They're just visuals. It's like a snapshot. There's nothing dynamic about it. And most noticeably, there's no logic. If you were to read any scheduling practice standard, it talks about vertical integration within the level 3 and horizontal integration within the level 3. But when it comes to intermediate schedule summary, it talks about vertical and they leave out the horizontal. You know, so I mean, that's just out of sight, out of mind. Well, that's useful, but we want to do better than that. So this is where we have arrived, albeit we're in the process of getting it all in the computer and available at some point. You're going to have a source schedule, usually a detailed. The source is going to generate for you, we call it, it's going to zoom up. It's density zoom up because all kinds of zooming options. And it's going to keep it synchronized, and you can switch back and forth. A multi-level hierarchy of vertically and logically integrated schedules, network-based. Instead of saying vertically and logically integrated, if you're with me, that's a mouthful. We're just calling concordant. The first time I let loose on the term, my schedulers say, what? So I'm including some synonyms for you, so you get the, you know, the gist of what I'm trying to say with concordancy. All right, so we go up, we can zoom out, we can zoom in. So a concordant multi-level schedules, if integration traceability goes beyond dates to include links, logic ties, total flows, critical paths, benchmarks, and milestones. By that, I mean, not only can you carry over, let's say out of 200 milestones, you may roll up 75 of them, but the 75 that you roll up will be logic tied to the summarized activities exactly the same way that they're logic tied at the detail level. So it's an algorithmic model all the way. Now, terminology-wise, zooming up is what we call the step of generating and synchronizing a summarized lower density schedule from a detailed source schedule. That's sort of that happens when you create it and when you update it. Zooming in is swapping the schedule display from level 1 to level 3. That's zooming in. That's kind of like Googling, you zooming into Google, doing the minus or the plus, and you get that. Zooming out is you're level 3, you swap to level 2. And now, you know, you got less detail. So that's, I mean, this terminology is really borrowing from how it's being used elsewhere. So I think in that respect is pretty appealing. I do want to point out that there are two applications of zooming up, density zooming. The first one is the one that I've been really alluding to all the time, which is hierarchical zooming. This is a disciplined approach to coding schedules on a work-breaking structure, creating swim lanes, and that stays for the duration of the project unless you got to tweak it somewhere. So it's hierarchical. It's following a express hierarchy in your detailed schedule. However, there may be other times where you want to take a portion of the schedule, or maybe you only have a level 3 schedule on a construction contract, but you need to get together with the superintendent to solve a problem. You basically, you will zoom in to a portion of the schedule, summarize it, get together with your stakeholders and make some decisions. Unless you file that for historical purposes, you're never using it again. We call that ad hoc versus hierarchical. What structure do we follow? And you saw this yesterday. Whether it's WBS packages, hammocks, organizing codes, in each case, designating a swim lane hierarchy and your detail schedule, that's the structure we're going to follow. Those are the Lego pieces. That's how the puzzle is going to be put together at a lower density schedule. But, you know, they're also inferable summarizing routes. If you have not the schedule coded that way, you know, we envision you clicking on a bunch of activities, getting the mouse around activities and saying, create parent. And when you create the parents, logic will be automatically be rolling up, summing up as you add activities. At some point in time, years from now, I suspect, the software will have learned so much how we do this, all the words that are in play, that you can probably rely on the software to an extent to do your summarizing for you using learn features. That's totally machine learning to another level. So how do we zoom up? How do we summarize the schedule so that we achieve activity concordance? Repeating myself, each source, WBS package, hammock, level code, or cluster is we call it a parent activity in the machine generated lower density schedule level. That's a parent. The source activity, the underlying detailed schedule that sets the parent early start, the bookend on the hammock, and the one that sets the other finished bookend on the hammock, so to speak, we call those the parent start child and finish child. If there's a tie, we take the least total float. However, we have to recognize that there may be activities embedded within a parent with less total float than the bookend, so we have to recognize that we call that the middle child. Other properties, you saw some of this yesterday. You'll have overall duration. That's simple. That's a hammock, duration. Net duration used to track not working periods because you're going to have some gaps in there. Of course, we're going to calculate for the parent activities all the GPM flow parameters and even a new thing called minimum float at the summarized level. And of course, if with Summit, because it is GPM based, you'll have a live schedule left of the day-to-day, what I call our current critical path until you complete the project. How about logic tie concordance? A logic tie and the detail, the underlying schedule sums up, rolls up, if you wish. If any parent, start or finish child, is linked to another parent, start or finish child, the algorithm will automatically propagate the logic. However, if there are any parent, start and finish child open-ended, because they're not connected to another one, then we're going to bring the logic tie as well. And where you have start to start, finish to finish dual logic at the detail level, we take the one with the smaller gap unless you specify otherwise. And the first time I shared the spec months ago with our team, the first thing they said, please, pretty please, no start to finish logic. And I said, oh, okay, I get it. Sorry about that. But the thing of it is, if you follow the concordant logic tie protocol, you are going to get start to finish links. In fact, out of the 12 logic patterns between start child and finish child, 5 of them are going to naturally be birthed start to finish. Anytime you have a loose end start or finish child, it's going to be corrected start to finish. So we created the algorithm to basically switch out start to finish and instead create finish to start and finish to finish links, and to achieve the same day concordance and horizontal concordance. Now, last but not least, when it comes to events, there are 6 ways that events logic ties and therefore event total float roll up. Clearly, if a milestone and the detailed schedule is preceding a start child, shoot, easy thing to connect. Also, if a detailed milestone is following a finish child, should you just link it? It gets a little more complicated when it's not as easy as that. Like for instance, if we have a milestone event preceding a finish child, you're going to have pop a finish embed and connect it to the milestone. In some senses, it would be pretty difficult to do zooming up, density zoom up with just the standard CPM algorithms, even for logic. But I guess with a lot of arm waving, maybe you could, but it comes naturally with GPM and LDM. So to get down to the epilogue, so to speak, it is a challenge to manually build a summarized network-based schedule. It takes very seasoned, skillful schedulers, which Lord knows there's plenty of us out there. Lord knows, the good Lord knows that we got more than our fair share, which is why we've been in business for 50 years. But, you know, it can be done, but it's very distracting from everything else you got to do. So hopefully I've persuaded you that density zooming will do it for you in full concordance, either hierarchically or just on the fly. When I first got into scheduling, we talked, you know, so when I first got into scheduling, we were doing level 1, level 2 schedules manually. Then the computer came on, a powerful computer with a powerful software. In 1967, 1969, it got a new, and then we started to say, shoot, you got to use the software. Our clients were saying, hey, you know, we want to see a computerized CPM. So we started to go to computerized schedules, and, you know, and they got bigger and larger. And right away, you know, general superintendents, project managers would say, well, can I see the schedule in some summarization? And we would say, yeah, we can, you know, and we do it manually, or we build another one. I mean, it was a lot of work. You know, I mean, with all modesty, I graduated from Michigan, got my PhD. Within a couple of years, I was chief scheduler for the largest contractor in Michigan, because they trusted me that if they said to me, this is roughly the strategy, that I could build a level 3 schedule that would mirror that faithfully. And I think a lot of us make a living because our clients, our stakeholders recognize that. More power to all of you. Navigating the schedule, you know, this is kind of like the frosting on the cake. Not only do we have this to happen, you know, quickly, but we can switch between different views, you know, like Tim said, you know, we've been Googling, so to speak, schedules, with summit viewing schedules, and etc. And you can pan 2 levels on the same screen. And at the end of the day, when all is said and done, and we release the software, you're going to have 4 ways to zoom in and out of a schedule. You're going to have density zoom up and zoom in and out. You're going to have screen zoom, which is magnification, calendar zoom, the time scale itself, and selectively, you can have different time scales on the diagram from different periods of your schedule, and then auto density zoom. When because you're collapsing the time frame or the vertical gridding, fragments miniaturize, so you have to, they automatically sum up to the next level. And once you stretch out the time scale, then revert back to the previous schedule. You know, Sebi demonstrated this yesterday. I mean, even though I'm behind this and we have an amazing team, you know, I haven't been around the horn for so long. I'm still wide every day, and I can't wait until, you know, all you colleagues and the rest of the world have the opportunity to try this out. What's going to be, why it's going to be going on with us in the future? Why are we creating all this software? We're not trying to replace the scheduler by any stretch. We want the software to not tax us. We want the software to help us have more accurate and far more useful models. We want to put boxes thinking to bed. We want projects to complete on time. Like Sergio showed yesterday, 75–80% projects finish 10% behind their intended schedule. That's insane. The amount of money that's costing us. That's got to end. And we are on a mission to help do that. And we think the software is what's going to help us accomplish that. So, because we're not short of super duper schedulers, and it's still not happening. And we want schedules that are reliable, that are accurate, and everyone understands them. And we can do that when you can zoom in and out, navigate it. And again, we want to make this thing effortless. No printouts, no F9 button, shock the schedule to do something. Just happen like us talking, like us communicating. And of course, we're going to be completing the zooming up algorithms in software, and we'll be able to do that. And if we'll be so fortunate to have you join us next year, I'll be introducing the whole deal of machine learning schedules, which our next adventure, and I'm super excited about it. Having been an academician, I have to always have my reference list. So for those of you from academia or interested, everything that you need to review to double check what I'm talking about, why is all there. Thank you so much.